Hey everybody, and welcome back to our second week of online classes. Hopefully everything's going really well. If you guys have any questions, again, feel free to email me. So let's go ahead and jump right in. Today we'll be talking about phase changes. Now, last week we talked about three phases of matter. This week we are going to be talking about phase changes. So first thing, all matter is made up of tiny particles such as atoms, molecules, or ions. And if you remember, we had atoms. Now, atoms have two parts to them. They have the outside area, which is called the orbit, which contains the electrons with a negative charge, and the inside area that's called the nucleus, that contain protons with a positive charge and neutrons with a neutral charge. So each of these particles are going to attract other particles. Now here's an example of a bond or an attraction. This is a hydrogen bond. There's actually a video you're going to watch tomorrow that actually explains why ice floats as opposed to sinks like other objects would as a solid. So again, that was a picture of water. In a solid, the particles maintain a constant shape and volume, and you had that last week. And you remember, actually, I want you to go ahead and draw this down. So you just need to draw in your guided notes that you should have printed off this front section here. So these are molecules that are closely packed together. With these lines, you can see that they're vibrating in place. And go ahead and draw that in your first box. In a liquid, these molecules are still close together, but they're free to move past one another. So just like they were packed in before, these are about the same distance apart, but now these molecules start to slide around and start moving past one another. They have a little bit more energy. In a gas, however, these particles are moving at a very high speed, and it's randomly in all directions. They're really spread out evenly. And it's almost like hitting the bonus level on a pinball game. These molecules now have a lot of energy, and they're just whizzing around all over the place. Because these gases have such large spaces between the particles, they're easily compressed into smaller volumes, meaning we can pack a lot of them into a small area. If your parents have an air compressor at home, it's actually just taking a force, applying it to a gas, and moving them closer together. This actually happens with things like propane, where if you move the molecules close enough together, they start to resemble a liquid and behave as such. So, in general, substances that are gases have the weakest attraction between particles, and substances that are solids have the strongest attraction between particles. So, shifting gears here a little bit, thermal energy is going to be the total kinetic and potential energy of all the particles in a sample of matter. Or what we're saying is thermal energy is how fast these molecules are moving. Now, if we observe these two pictures, which one do you think has thermal energy? Well, obviously the one on the left here, the sun, is going to have a lot of thermal energy, but what most people don't realize is the one on the right also has thermal energy. The molecules are moving in place. Not a lot, but because the molecules are moving, it's still going to have some thermal energy. So temperature. Temperature is going to be the average kinetic energy of the particles of a substance. And this is usually measured in degrees. Sometimes we measure it without degrees, and we'll talk about that here in a second. The three scales we're going to measure are Fahrenheit, which we're used to. It's what we use in the United States. Celsius, which the rest of the developed world uses. And Kelvin, which isn't really measured in temperature. It's actually a scale from 0 on up, which 0 being the coldest thing the coldest temperature anyone could ever get. Molecules would be completely stop moving at this point. Kelvin was referenced in that Bill Nye video you should have watched last week. Okay. We're going to reference heat as the flow of energy between two samples of matter because their difference in temperature. And we have, wrong picture. There we go. So we have heat being given off by this example. So when we add heat to a substance, thermal energy increases. And when that thermal energy increases, it causes molecules to speed up, and they also spread out. If we add enough thermal energy to a substance or taken away from a substance, we can actually change the state. And we will start with our first one here. So what do we call it when a liquid turns into a solid? And we call that freezing. So you can see here that looks like snow melted and then was frozen to the front of this vehicle, and then it backed away. When a solid turns into a liquid, we call that melting. And again, here the Wicked Witch of the West is turning from a solid to a liquid. When a gas turns into a liquid. So we have a gas turning into a liquid, we call that condensation. And an example of that would be, say if you have a cold soda on a hot, humid day in the summer, you would call it sweating, but it's actually just condensation on the outside of the can. When a liquid turns into a gas, call that vaporization. Now, examples of that would be evaporation and boiling, but in this case, in general, we call it vaporization. When a solid turns into a gas, call that sublimation. And an example of that would be dry ice, which is actually frozen carbon dioxide that turns directly back into carbon dioxide gas. And when a gas turns into a solid, we call that deposition, which an example of that would be water vapor in the air in the winter getting so cold it freezes directly to glass, and we call that frost. All right, I went through that kind of quick, but remember you can go back through, pause the video where you need to, and fill in the guided notes. If you don't have the ability to print the guided notes, please take notes on a piece of lined paper. Later in the week, Thursday, we actually do have a lab coming up. So if you want to do that on the weekend, maybe your parents go shopping, like on Friday or whatever, there are some supplies you might need, but you should have most of that. And it is a lab where you'll be demonstrating phase changes. Let me know how it goes if you guys actually do that. Shoot me an email and tell me how it goes. Okay? Hope everybody's enjoying your break, and I will talk to you guys next week.